Our next speaker is Dan Gillman. He's a research mathematical statistician from Bureau of Labor Statistics and he's for data classification initiative.
Good morning, everybody. So instead of standing, I'm going to sit, and I hope that's okay. Let's see, where is my talk? So I found Fraki's talk very interesting because it's looking at metadata in a way that many of us that have been thinking about metadata in the statistical community haven't gotten to yet. Although there are developments in this direction which I think will eventually solve some of these needs, and I'll try to talk about this as we proceed. So what I'm going to talk about are standards and talk about them in general. What do we mean by a standard? And talk about this idea called interoperability. People throw this term around, and I don't think that it's very well understood. And then talk about the case for standards and talk about this from the point of view of a simple data integration scenario that's a little bit out of date, but it's illustrative nonetheless, and then have a short overview of some of the important statistical metadata standards that are in use. So there are lots of standards, and there are lots of organizations that develop them. But you can evaluate a standard by looking at how that standard was developed, the organization, and what they think is important. And there are 5 criteria, and the most important is that the agreement process is consensus-driven. In other words, there isn't someone that's saying, well, we're going to do it this way, and this is just the way it's going to be, and that's it. There's a consensus among the people that are developing the standard. The process has to be open. That means anybody that's interested in joining the development process can. The process is transparent. That means the steps in the process are available to anybody to inspect. The process is fair. That means that everybody has the same rights. There's no organization or group of people or even a single person that has more say than anybody else. And then finally, that it's balanced. In other words, the various groups that might be using the standard are fairly represented among the group that is doing the development. And there, as I said, there are lots of standards organizations out there, ISO, the International Organization for Standardization, World Wide Web Consortium, the National Information Standards Organization, the DDI Alliance, which I'm going to talk about, and the UNECE, the Economic Commission for Europe, the UN office that's in Geneva. So there are 2 quotes here that are similar that I've always enjoyed. One person, Karsten Rasmussen, who's at the University of Southern Denmark, once said, standards are great, there's so many of them. And then Adrian Tannenbaum, who was a consultant at the Census Bureau when I was there in the 90s, said, standards are useless, look at the second S. So there's different ways of looking at standards. Karsten's approach was to say, well, there are lots of them, and they should be able to cover most of our needs. Adrian's problem was, well, when you have a particular problem, often there's multiple standards from which you can choose. Which one do you pick? Is that obvious? And so part of what I'm going to be talking about is, well, what do we pick? So interoperability. interoperability is in general the ability for one system to work independently with some or all of another system. If you need to call somebody up to ask them how to use something, well then that system isn't interoperable. And so the idea is to have the ability for a particular person or system to use the resources at hand independently. The idea is often applied to computerized systems, but it's also applied to data. So for data interoperability, we want the ability to use data from another source without help from that source. So what does this mean with respect to metadata? We need a lot of metadata to be able to do that. Do we have it? No, well, no, not all the time, probably not even ever, but we'd like to be able to achieve that. The thing is, though, that metadata are also data. And so the data interoperability question also applies to metadata. And so then that begs the question, do we need metadata about metadata? Well, let's hope not. Because if we have a shared model, if we have a standard that says this is what our metadata looks like, then we don't really need the metadata about the metadata because we have this framework from which to reference. And so we don't have to write this down. It's out there. We can have access to it. So my main point is that if we have to keep talking about the metadata, if we have to keep saying we need metadata to describe the metadata, that's an infinite ladder. Okay, we're going to keep going and saying, well, we need to describe this, we need to describe that, we need to describe that. We don't want a world like that. We want that ladder to end, and we want it to end at the metadata level. So, all right. So we're talking about standards and interoperability. So why are standards important? Well, first of all, if we apply a standard to a problem that we're trying to solve, that eliminates or reduces a lot of the design effort. And it increases the chances for interoperability because we can share that design. But standards are neither necessary nor sufficient for interoperability. We have to have a little more. We have to say that we're conforming to a standard, which is a very precise statement. It means that we're satisfying all the requirements that the standard conveys. And that's actually a pretty strong statement. It's hard to achieve, but it means that systems can be built independently, and yet by saying that we conform to a standard, different systems can talk to each other. By saying, okay, I know how to read your metadata because I know what your system looks like. I can write metadata that your system can read because I know what your system looks like. But if we use different specifications, if we're not sharing a standard that we both know about and conform to, then we need to make a translation. And those translations are not always exact. And so we run into problems because we're in a way talking a different language. We have 13 principal statistical agencies in the U.S., not including OMB. And if we have to translate among all of them, we have 78 different pairs of translations among those 13. And that's enormously complex. And we're not going to write systems that do that. And so we need a better way. So adopting standards reduces the problem. Now, there's still the problem of the second S, which is there are many standards to choose among to solve a particular problem. So, in trying to make sense of this, first of all, when you're choosing among standards, don't try to fit a round peg into a square hole. Standards have a scope associated with them. That means they were developed to solve a particular problem. I've been around standards development organizations for a long time, and what I find is that the adherents of a particular standard try to increase its applicability. They say, oh, well, you can use it for this problem, you can use it for that problem, and ignore the fact that there are other standards that have been developed to solve the particular problem that they're trying to expand their standard into. It's better to stay within the scope of the standard because that's what the standard is trying to solve. Don't use a standard beyond its scope. So in talking about that, I want to illustrate the use of some standards through a data integration scenario, a simple one that I found out about some years ago. And what I want to talk about is the content standards. That is, the standards that talk about the metadata that we care about, not about the infrastructure, not about the computing environment, and so forth. But I just want to give an overview to give a sense of what I'm talking about. So there was a paper written in 2009. It appeared in Forbes magazine called America's Safest Cities. And this guy, Zach Greenberg, came up with a way of measuring this, all based on the negative. He said, well, let's count the workplace fatalities, the traffic fatalities, the violent crime, and the natural disaster risk. And I thought, okay, well, that's a negative way of looking at the world, but nonetheless, he did this and ranked the cities. So, and he did this based on MSAs and a numerical ranking for each of the measures and summed them up. Very simple. But so reading the article, there wasn't a lot of reference to what the data was, and so the question is, can we find and understand relevant data to answer the questions that this article posed? And so the first step that we need to take when we're looking for data is what the community often refers to as discovery. Can we find data through search? Like, can we use Google to find the data? Well, for me, when I was looking at this, the answer was no. But what was interesting was I could get to the right agency. The workplace fatality data, this paper was interesting because it used BLS data, the workplace fatalities, and so that's why I spent some time with it. And when I searched, okay, I said, okay, well, this will point me to BLS, even though I already knew, and pointed me to other agencies as well. And so what I found was I could get to the right agency, but I couldn't necessarily get to the right data set. I actually had to dig around into the agency websites to find the right data, and more importantly, I had to dig into the data sets to figure out what variables I had that were available. So the discovery problem is difficult. It hasn't been solved in what I would call a transparent way to yet. And most importantly is if I do a discovery, am I guaranteed to find all the resources on a particular subject? And the answer is, I don't think so. So there's a big problem out there. So one way around that is to think about having a catalog or a registry of all the data sets. Think about a library card catalog. It has a catalog entry for all the books in the library, and you can locate them. But the registry or catalog would be online. Data.gov is an effort to produce such a catalog of data sets for all government data. But there are other catalogs in existence. Museums like the Smithsonian Museum of Natural History has catalogs. The Library of Congress has catalogs, and so forth. So turns out there are a lot of relevant standards for cataloging data sets and discovery. For data.gov, they developed a standard for describing data sets that data.gov would catalog. They called this the Project Open Data Metadata Scheme, and this was open and transparent enough that it really satisfies the criteria for a standard. More generally, there's the Dublin Core Metadata Initiative, and many of you have probably heard of this, and it's a general standard for describing resources at a very general level. The MARC standard is for doing books online. There's a standard called Metadata Registries, the ISO IEC 11179. It's actually about the semantics of data, but registering these things you care about data. I'll say a little more about the standard later, but it talks about how to describe data and how to have a registry of those descriptions. DCAT, which is a Worldwide Web Consortium standard, is a general standard for data catalogs on the web, and is developed for using web resources. And then the Data Documentation Initiative, which Frauke mentioned, is also a standard for describing data sets. It describes more than that, but you can use it to describe statistical data sets. So in our scenario, in discovery, we can discover that there's workplace fatality data at BLS, there's traffic fatality data at the National Highway Traffic Safety Administration. But how do we know which particular data set to select? And are there several? We need data dictionaries to be able to determine that. And so when we look more deeply at the data, we discover which data sets to look at. At BLS, there's data based on MSAs, but the number they're just given as numbers, not as rates. At the National Highway Traffic Safety Administration, the data is based on cities, not MSAs, but it's based on rates. So there's a data integration problem associated with this, as well as this whole discovery issue. You need to dig down into the data to figure out what these discrepancies are. So we need a data dictionary. And when we talk about that, what do we really mean by that? Well, we want descriptions of variables or measures, which might be quantitative variables on aggregates. We need to describe code lists and classifications, because that tells us what the categorical variables might look like. We might care about what the questions were if we use about a traditional survey, and maybe something about the methodology. And with the more modern approach that Frauke was referring to, there's still a methodology involved in getting this data, and we need to know what that is. And so the data dictionary might talk about that at least at a high level. And we need a description of the variables at a minimum. Whoops, what happened? Oh, I didn't mean to do that, sorry. So I pressed the wrong button. So we're interested in all this stuff, and we need to think about a level beyond discovery. And most of the discovery models, the ones that I mentioned, don't account for that. Some of them do, but most are just at this high level, and there's little in the way of accommodation for this additional information that we might need. So let's look at data dictionaries. Well, as I mentioned, the ISO 11179 standard is about variables and can talk about a data dictionary. The DDI comes in two different forms. One's called codebook, which is essentially, okay, I've done some research and I want to document that. And that's what the codebook is for. Lifecycle is more advanced. It's for describing what statistical offices do when they acquire data, process it, make estimates, and disseminate it. The UNECE has developed a generic model, GSIM, called the Generic Statistical Information Model, that does essentially what DDI Lifecycle does, but GSIM is a more high-level conceptual model than what DDI is. There's also an interagency committee that I chair. There used to be a group called SCOPE, and they created a metadata subcommittee that's interagency. That group still exists, and we wrote a specification for data dictionaries that we asked data.gov to incorporate, but they haven't done that yet. There are also methodological issues around what the questions look like and their ordering and the sampling and post-collection processing and post-collection estimation. All of this can affect analyses, and there's standards for documenting all of this too. So we can get into an enormous amount of detail in talking about our data. Now, as I mentioned before, this is a fairly traditional view of what statistical agencies do and is not so forward-looking, but a little more about that in a minute. So what sort of standards exist for describing methodology? Well, DDI in both codebook and lifecycle can get to that level. GSIM, the Generic Statistical Information Model, and there's also something called the Generic Statistical Business Process Model, also done by UNECE, that looks at the process of acquiring, processing, estimating, and disseminating data. And in fact, GSIM and GSBPM are meant to kind of work in conjunction with each other, be sort of duals of each other around the process and the information that you want to talk about when you're describing what goes into and out of a process. Sort of a merge between what Frauke was talking about with paradata and metadata. So I want to talk a little bit about the efforts that are going on around metadata. There's the SCOPE group. SCOPE was called the Statistical Community of Practice and Engagement. It was a group to leverage common practices among the agencies to try to reduce costs and increase sharing. And they formed an interagency group on metadata. And we produced the first data set description for data.gov, although it was geared towards statistical data sets. And then we produced a data dictionary that can talk about the basic variables and measures and so forth. We meet biweekly. We need more participants. If anybody's interested in joining, I highly recommend that you do that. Contact me. We can easily get you onto the group. In the ISO 11179, the nice thing about this standard, it's an ISO standard, it's actually freely available on the web. And I've produced the URL that you can go to get to it. It was really the first standard that had metadata in its title. It's model-based. It focuses on metadata that you can reuse and connect, having a fairly robust, interconnected world of metadata. It also talks about the operational needs for a registry or a catalog to maintain the information. The standard is built in 6 parts. I won't go into the detail, but it was actually used as the input for the development of DDI, GSIM, SDMX that Frauke mentioned, and I'll mention a little bit, and the scope metadata work. And as I said, it's freely available. GSIM and GSBPM were both developed under the UNECE, the UN Economic Commission for Europe. UNECE comprises Europe, Canada, and the U.S., but it oversees a number of statistical cooperative programs that are worldwide. GSIM and GSBPM were developed under a broad modernization effort that's centered there, and many countries are involved in this effort: Australia, Canada, New Zealand, the U.S., France, Italy, Netherlands, Portugal, all the Scandinavian countries, and Slovenia. I've probably left some out, but it's a wide group of interested organizations. So GSIM, and here's a link to it, is a model of statistical information objects. What do we care to describe when we're talking about what it is that we do? There are 4 main sections to GSIM: conceptual area that talks about variables, the structural area that talks about data sets, business area that talks about what we do, the processing, the designs, and exchange that talks about dissemination, how to acquire data, and this is a very modern view. So if we have data that's non-traditional, GSIM actually talks about how to bring that data in. But it's a high-level conceptual model. It's not directly implementable as it is. There are no bindings to this standard. That is, there's no way to actually implement it in a turnkey way. There's some effort to build an implementable model called the logical information model, but it really hasn't gone that far. And I don't recommend actually using GSIM or starting with GSIM because there's a lot of work involved to have to actually build a system based on it. There's GSBPM, which is an outline of the statistical life cycle. It has 8 main phases. Each phase has subparts, and it's been adopted by several agencies here in the U.S., and it's used often to classify IT efforts and systems associated with the various survey and statistical work that we do. BLS has done it. Census has done it. There are probably other agencies as well that I'm not aware of. Then DDI. So DDI has been developed under what's called the DDI Alliance. This is a consortium of data libraries, archives, producers, and researchers. There are 2 threads to DDI, as I mentioned before. There's the code book, which is essentially a data dictionary, And the metadata is not reusable. It's standalone. It requires actually that you do searching on the elements that are defined in a code book in order to be able to make comparisons across different instances of the code book. But those searches can't guarantee that you found all of the metadata that might be available, and it's hard to link metadata across different code books from one to the other. The lifecycle standard, on the other hand, is, number one, it's GSBPM based. The metadata are reusable. You can share them. You can connect them together. It allows for an extensive description of methodology. It includes everything that the code book has. And it's what's called a profile of GSIM. So in other words, if you take GSIM and take DDI, DDI accounts for everything that GSIM talks about. It doesn't do it in the way that GSIM does, but both codebook and lifecycle are based on XML, which means that you can actually take the XML and create databases out of the box. Plus, there's university-built and commercial software that interacts with DDI, and so there's the capability of actually building systems based on DDI almost immediately. Now, it's not turnkey in the sense that you can just get this stuff, install it, and all of a sudden you're using DDI. There's a learning curve, but you don't have to build you don't have to think about building a system yourself. DDI provides that for you. And their yearly user conferences, the North American DDI User Conference, which was held here last April, and the European DDI User Conference that's held in the beginning of December in Europe. Anybody that's interested either in developing, using, or thinking about using DDI can come to these conferences and learn about DDI. It's a robust community. SDMX is another. They call it a standard, but it wasn't developed under the same open framework that I described at the beginning of the talk. There were 7 international banks and statistical offices that got together to build SDMX, Bank of International Settlements, the European Central Bank, Eurostat, which is the statistical agency of the EU, the International Monetary Fund, the Organization of Economic Cooperation and Development, the Statistical Division of the UN in New York, and the World Bank. But what what SDMX does is it's designed to exchange dimensional data. So any cube data that we write in tables or time series or other time dimensional data, SDMX is designed to handle. Many of the U.S. agencies right now use SDMX to transfer national indicator data to IMF as part of their program to manage national indicators around the world. It's based on XML, so it's implementable, but it's complex. It does have a complex learning curve, but it also has a very extensive installed base. There are yearly user conferences that allow you to find out what's going on. I haven't ever asked one of the organizations that's used SDMX to see if some of their systems could be shared, but I expect that they probably could be. But SDMX is really a standard that's designed for exchange. It's not so much designed for doing the development of data the way DDI is. But an agency like BLS, we're using SDMX, and we could use it some more. It has a place. DDI, on the other hand, we're also using. it has a place. So these two standards can be used in conjunction with each other. And that's pretty much what I wanted to say, so I can entertain questions if there's time, otherwise we'll move on. So does anyone have any questions? I know I said a lot. And I hope I said things that dovetail with your thoughts, Roger.
Yeah.
Well, without trying to make, so for those of you online, the question is what problems have we run into regarding the use of DDI and SDMX? I guess the main problem is the time and expense in gaining the expertise to actually use the standards the way they're designed. Some years ago, here at BLS, there was a system developed for moving data from the programs into our time series database. And I recommended that we use SDMX because it's designed explicitly for that problem. But it was seen as too complex, and so it wasn't adopted. And the adoption of SDMX here to move our indicators to IMF actually succeeded because another agency built the infrastructure in order to be able to do that. So one of the problems is there has to be a commitment, and people have to recognize that using these standards does take some time. And if you need to solve a problem quickly, it goes against the adoption of standards because standards take a little bit of time to get used to. We'll hear much more later today about our use of DDI at BLS, and so I don't want to steal their thunder, but we're making progress with that. And there's a very interesting application that's being developed. And we're using some commercial software that enables us to adopt and use DDI without having to know that much about DDI at the start. Now that means there has been some expense made, but over time I think that's going to be worth it. Any other questions? Or does anyone have any questions of Ralphie? I kind of have a question, which is, I found what you were talking about concerning the tweets and Facebook data to be really, really interesting. And I'm interested. You said, I believe, that there's a JSON spec for describing the metadata that describes individual tweets. Is that right?
That's right. So on the Twitter documentation site, you get information on what's contained in a particular JSON file. But the JSON, the way JSON files are written, they also have key information in it. Right? But the main point, though, is that the structure is much more dynamic. So what you describe, implementing all these standards, it seems to me it works very well for a data set where you ahead of time know what's in it, or where at any given point of time you know it, and then it doesn't. I mean, I guess it can change, but it changes within an expected range, right? But if we are in this multiple data source world, which the spread here is, right, we are likely faced with data sources where that's not the case, where you didn't upfront have the possibility to define or know what's in each column, what the variable name is, what the categories are. And where, because the processes that generate the data change over time. So that's where I think we have to have an eye on these standards, whether that breaks down. Because what you described, meeting every 2 weeks and getting this implemented and how long it takes these standards to get developed. Well, by the time the standard is developed, that data set has changed so much, or the way the data are produced, that we will always, I think, be hobbling behind to what our information needs are. That's the risk I see, and I think that's the debate we need to have. Like, how do we? And I'm not saying we should throw all the standards out. That's not the idea. But it's just difficult to implement this with these other types of data streams.
Well,
I actually would like to respond to that. Part of that problem is not the development of standards, implementation.
Oh, okay, fair enough.
So even in data sets that evolve, the basic concept of a variable and what you might like to learn about a variable is not that.
Right.
So the evolution of what the coverage is, because the evolution might change. Ultimately, it goes back to, at any given point, to pick any of these standards to describe to some level of precision what it is you want to do. The problem is, at some point in time, the content will change.
Right.
How to keep track of that and how to link those is sort of a meta standard, if you like.
Right.
That isn't well defined in any of the cases. Life cycle, one code to the next.
Right.
We use it.
Right.
We think of that possibly in nice sequential categories. This year's data set, this is next year's data set, and they have some relation to each other, but they're not identical.
Right.
That already happens with surveys and other things as well.
Right.
That is a known problem. The trouble with some of these other ones is that we don't know when Twitter added this additional variable when it started appearing. So empirically, we can determine that because the fundamental problem is not so different in that dimension.
I'm glad you mentioned that, because I hope that came across. I really value all that work and thinking that went into it. And so what you described, I may put this in a slightly different word and see if I capture what you're saying. It's like, behind all these standards, there is a framework of thinking about the data, right? That you have a variable, that you have values in a variable. And we need to have a way of identifying these pieces across whatever the data source is. So we have a sort of, as you said, meta structure in mind on what we want to know about a data set. Why, a unit that you want to grab needs a name, otherwise you can't grab it, right? It's just that, well, if you want to send, if you want to send a piece of mail, you need an address, right? That's sort of the kind of interchange elements that we need, no matter whether you send a letter or a package or a fax or what have you. So I fully agree with you on that. What I think though is that as you said, in the implementation, in specifying the details, most of the work, and I caveated earlier that there might be developments that I'm unaware of, but most of the work feels to me often that there's so much predefined categories where then fill in that information that if the data changes quicker than these exact specification, or as you call it, implementation, then I'm at a loss because I don't know how to further categorize it. And because these data sources that are not designed by us, that come from other places, most likely we are ingesting them and we're creating a new data set, right? So we make decisions about how we want to combine variables, and we do all this in the context of our own research question data needs. And you mentioned that, right? The standards and implementation are created in a context, right? But if we are we all want this data to be used again, or at least increasingly so. We are opening up the data we produce. And the next person using it, they might want to use the data in an entirely different context. So my decision on how to categorize the values that came in, and yes, I have a nice documentation. Now I have 4 categories, and they all mean the following thing. If I don't also have a way to to describe and capture and keep the process on how I categorize it, even as simple as the code that led to it, right? Then the next person for whom that categorization is not perfect can't use the data in an optimal way, because for them, maybe they would have needed to do a different categorization. And so that's, I think, what I mean with sort of keeping track of the paradata or the process that led to whatever feels into the implementation, because we all are using them only in a different context, and the way we choose to document is relative to the context. It might not work for the next person that has a different research or reporting question.
Without trying to say how great DDI is,
You can.
I do want to say that standard is evolving. And there's a lot of work going on right now to add to it. And one of the areas where additional functionality is being added is with describing what they call methodology and process.
Okay.
And a very detailed ability to tie designs and process together and string them together to be able to show all that's happening as you're moving data from acquisition to dissemination is being developed. So I think just hearing this short you're saying, I think that those kinds of problems are being addressed. And one of the interesting developments in DDI is the idea of taking data and being able to say, okay, well, right now, I care about this group of variables. I care about these two variables as my important variables that I'm measuring, and these other variables as attributes. But that can switch, and I can apply the same labels to different sets of different subsets of those variables because I have a different analysis in mind. And so there's being added a lot of flexibility that older metadata, more brittle metadata descriptions didn't have.
So just a quick response to that. I clearly need to visit these bi-weekly meetings because I'm glad to hear that. I wasn't aware of that latest development. I had another thought when I listened to your talk, and I saw your hand just a second, that if we take the picture analogy that I made, right? I mean, a lot of that is captured automatically by our devices, spit out in different format. And I think part of the challenge here will be to make some of that process documentation sufficiently easy for those that work on the process. Because they all have to learn first what's we've used so many different software, so many different packages, and unless it really integrates nicely, I would not go through the trouble for every picture that I take, write down when did I take it and where is it, and put that into a separate category and format. If it weren't captured automatically, I would just not have that information. And so that's the piece I think that we need to keep in mind. That it needs to be easy.
Metadata collection is a huge problem.
It's also important.
Yes.
I have a comment which I will mutate into a question at the end by asking Dan, do you agree? Okay, so here's my
Nicely done.
forums, right? We really have comments, but
yeah.
Okay. My comment is I think that there's two fundamentally different processes that data users go through. And one only has very difficult solutions, the kinds that we've talked about today, and the other has, at least in part, a simple solution that hasn't been talked about today. reports know where we got the data from. And often, in my home agency, in other agencies that are represented here, we give very terse citations. Sometimes not much more detailed than Forbes or the Washington Post that would say, data source, U.S. Department of Agriculture. Well, wonderful. Which amongst the many, and then even getting to the web page of the source agency, you have to do some digging. So for being able to locate data that somebody else has used and is trying to provide a citation for, would a simple solution be we all need to simply provide a little more detail in our citation? That doesn't solve all the problems. Doesn't solve the first one I had of I'm trying to locate data that I don't know what it is or where it's at, but to locate the data that another researcher used shouldn't be a burden on me to figure it out, to be a burden on the author of the research report to give me a full enough citation. Do you agree?
Can I give a somewhat long-winded answer to that rather than just yes or no? First of all, yes, I do agree. But because DDI is in part coming from the research community, the issue of citations is huge, and so they've delved fairly deeply into the issue of how you reasonably do a citation for data. So, in part, I think your question is actually a two-part question, which is it a good idea to do this, the citations? And secondly, how do we do that? Well, the how, I think, has been addressed, and I agree completely that that citations should be provided. If you're writing a report and it's based on data, there needs to be a detailed citation to tell somebody how to get to that data as long as it's publicly available. Not all data is going to be publicly available, and there are reports, I'm sure, that we do at BLS where the results are based on data that we couldn't actually make public. So there has to be some kind of citation. I think what goes along with that, if we have a catalog of data sets and we can reference the entry in a catalog of data sets, that goes a long way towards solving that problem. Of course, that has to be maintained, but I mean, as long as we have the internet and the web, I don't see why that can't be a resource that we as I'll say balkanized statistical world can't produce.
So in the last 30 seconds, I'm just going to quickly answer. I think what you're talking about is related to this digital object identifier and last note.
Yeah.
I do, but that's attempts like that. You know, a DOI, a fixed number, could be added to an article, and then the data that's associated found with it. So that it is. There are already sort of attempts in place to do exactly what you just described. The other piece, and then my German half wants to help you get us to the break at 10:40, is that I think this week Google actually released an entirely new search that is called data search, where they much improved the way to actually find data sets. So anyway, the COPA meeting that's next door, if you follow their Twitter feed, you see a link to there, but obviously you can find that on Google as well. That's all I wanted to add.
Any other questions?
How important is that notes in the body? I'm struggling with it right now. So getting to the source, getting to the process all of these things serve different purposes, right? So I would approach this as what the information that a reader needs at the very moment they look at this, sort of on a high-level way. It's definitely good to have that there. But ideally, you have a way to point to a place where there's much more detail, all the way down to seeing the code that produced the table. That would be my quick answer.
I don't have a lot to add to that.